All right. Might have another couple people straggle in. But thank you guys for showing up to this talk. I know a lot of people have been going through the rigorous con schedule, so I appreciate you still being on your feet today to come see this. So the name of the talk today is Comparing Apples to Apples. The idea, comparing apples to Apple, rather. The idea being, like, if you come from a background where you haven't had to defend or attack a lot of Apple devices, which is a lot of organizations, this is supposed to be a practical primer for you to take techniques and tactics that you know from like Windows and then apply them to Mac so you can quickly come up to speed. So my name's Adam. I work for Ray Canary. These are a few of my favorite things. You can follow me on Twitter, but I wouldn't. I don't really do a lot of stuff on there. So all right, so here's the agenda. This is kind of what we're going to go through. So some really high-level macOS security overviews, kind of talking about like what they prioritize. We're going to go through a lot of different tactics and some individual techniques. We'll do some deep dives, kind of show you what it looks like to see evil stuff on Mac and how you can do it. Talk about some tooling, some open source free tools, and then I'll show you a little fun thing I created that you can use. Right. So Apple has kind of built macOS and iOS and all the other OSs kind of on three main pillars. So everything is kind of centered around code signing, entitlements, and sandboxing. So code signing is pretty straightforward. Apple controls all the certificates. They hand them out to developers as needed, but they're kind of like the one-stop shop. And as macOS continues to move forward, it's increasingly difficult to run things that are not signed, specifically by either Apple or one of these third-party developer-approved certs. Although there was a great talk on Friday that you should definitely check out if you didn't see it, on a cool bypass. Entitlements are kind of attributes that are assigned to binaries. So just by virtue of the fact that you are on an Apple system and running even as root, does not necessarily give you access to other processes, which is some of that sandboxing. If you want to interrogate another process, you need specific entitlements, like get task for PID, other entitlements like that. There's like a whole dictionary of them out there. And a lot of them, especially the most powerful ones, are reserved by Apple. So if you send something up to Apple and say, hey, I want to put this in the App Store, please sign it, they look at the entitlements and they're like, no, you can't have this, you're too powerful. So even if you're running with what you feel like is God mode, you're still restricted by some of these things. So all of these subsystems, which I won't get into in the macOS system, are kind of designed around enforcing these principles. Very resilient lattice work. It's really actually kind of intricate stuff. So just to kind of like pivot from there, you'll notice based on all that, it's kind of a hostile environment to bring your own binary to. So if you're an attacker, you're not going to necessarily say like, oh, I built this super awesome like rootkit or some other piece of malware. I'm just going to run and drop it on the machine and run it. There's a good chance that they're going to run into some problems. But Apple has made this really easy for them by giving them like every scripting language in the world by default. So just to kind of give you a taste of things to come. So like on the Windows side, if you're familiar with PowerShell, been used a lot in the last few years for like fileless malware, all kinds of different attacks, lateral movement, all kinds of cool stuff. There are some corollaries on the Apple side. So AppleScript is the most Mac specific. It's very fun. You can do all kinds of stuff with it, like execute software, run shell scripts. You can run remote code on other systems. You can interact with the GUI of any Apple process. So it's really rife with possibility for compromise. So we'll get into a couple of examples as we go deeper into the tradecraft, though. But then, of course, they have Bash and Python and Ruby and Perl, PHP. You can install PowerShell. And all of those, excluding PowerShell, you can't get rid of them. So you can remove them. You'll break some internal Apple stuff, and it will show back up the next time they update. So, and a lot of times there are older versions of it as well. So they might not even be the version that you need to execute the things you want. All right, so a couple of other things before we get into the individual techniques. We'll be using MITRE ATT&CK for taxonomy. So if you're not familiar with ATT&CK, all two of you, it's basically MITRE's wiki of observed adversarial behavior, tactics, techniques, and their tooling. So it's a really great resource, both as a defender and as an attacker, if you're trying to figure out, like, how do I go about learning a new platform. It's a great resource for that. And at the bottom there, we have the Mandiant attack lifecycle, so kind of the steps an adversary will go through when they land on the system. We're going to be mostly focusing on that loop there because that's where the attackers spend the most time. So the ways they get into a system change rapidly day to day, but what they do once they're in there, attackers are lazy just like everybody else, so they do the same thing. So we're going to focus mostly on that. All right, so this is kind of how we're going to approach it. So we'll look at the thing on the Windows side, we'll look at the thing on the Mac side. So who am I? Is who am I? Talk complete. There you go. No. So it's the same exact thing. It's who am I, it says who the user is. So net.exe on the Windows side is a common attacker tool, an admin tool to learn information about users, which groups they're in, group membership, other attributes. So there's two tools on the Mac side, so DSCL and dscacheUtil. Those are utilities that you can get all kinds of attributes about individual users, their group membership, other kinds of permission stuff. So just something to kind of keep an eye out for. System Profiler, I compared it to MS Info because I couldn't think of anything else that is as complete as System Profiler. System Profiler will collect all of your hardware information, your software information, your firewall rules, like user information. Like it's insane how much data this thing pulls. There's a little screenshot there. So a maldoc that we observed in the wild. It was running off all kinds of System Profiler individual attributes, looking for those things, and just kind of storing them all for recon purposes. So it's a really cool tool. And then, so like another thing, if you land in an environment, you want to walk around, see what else is out there. On Windows, a lot of times people use things like Nmap, other kinds of utilities to scan adjoining systems. So Apple has included a really cool utility that is little known called Network Utility, which has got like the ability to ping and do DNS lookups and stuff, but also has a port scanner built right into it. So you can port scan using nothing but Apple utilities. It can be called directly from the command line. So if you go to the stroke util, if you can, I don't know how big that is, but basically it just takes an IP, it takes the port range that you want to scan, you go. So you don't have to even bring anything to the table, although you can install Nmap, of course. All right, so let's look at credential access and privilege escalation. So changing tactics a little bit. So on the Windows side, if you have a command prompt and you've done a whole bunch of stuff, and somebody comes behind you and they want to see what you've done, they can use the DOS key command. They can use the F7 key. There's a lot of different ways to see the history of your command prompt. So because Mac has Bash natively, every user has a Bash history file. If you come from a Linux background, you're familiar with this, but basically just a list of all of the things that you've run in the terminal. Now, as an attacker, it might be interesting because someone might be, working with a system where they passed a password along the command line, or had some kind of identities file that they're referencing that's got username and passwords in it, maybe in a hidden file. Maybe they're just hitting a bunch of things on SSH, and you can find something that you already have keyed access to under this user's context. So the Bash history file is kind of a great one as a defender just to watch whether it's somebody trying to reference it, somebody trying to delete it to cover their tracks. It's a really easy win. DLL hijacking, direct corollary with dial-up hijacking on the Mac side. So basically the idea is you have a binary that's trying to call a series of libraries, and it's going to go through a search order. A lot of times, especially if there's lazy programming going on, they'll just be like, hey, I'm just going to search all the directories in this path until I find this thing. So what you do as an attacker is say, here's the binary you're looking for, here's the library. It pulls it into memory, and now you're running under the context of that process. So this tool is one that Patrick Wardle wrote from Objective-C. He's got like a ton of tools that are really awesome, but it's a good visual of where you might have some compromise. In user prompt, if you've ever run Responder to attack Windows systems, basically pop up something that says, hey, I need your password. Users love putting their password in boxes. You can do the same exact thing with AppleScript, and you can do it in a really clean, nice way because you're going to do it in the exact same way Apple would do it. So down here you can see an example of an Apple script that's run directly from the command line with OSA script. So each one of these E's is like its own little line if you want to visualize what the script might look like. But basically it says, hey, system preferences, open up, pop up a dialog box, prompt the user for their password, and then give it back to the shell when it's done. And that would look kind of like this. So I'm just going to paste the command. You see this software update. The user puts in the password. Super cool. And now you get, hello, DerbyCon. It's a great password. So usually you would be, as an attacker, you would be on the other end of a reverse shell or something like that. And so you wouldn't have a big box popping up for the user. So this is an example. So Eggshell is a post-exploit Python-based kit, surveillance-focused for Mac OS and iOS specifically. So one of the things, they have this nice little prompt plugin which will pop up that same kind of box, pass it right down the shell. The cool thing about Apple is if you have a single user, you are probably the admin unless it's been taken from you. So it's a very quick escalation to root if you ever get that user's password. So down here at the bottom, I have an idea for like a detection, looking for OSA script, anything in the command line that's focused on password, system preferences, software update. Look for the things that an adversary would use to try to get somebody confused. All right, and so another way, if you have that password, but you're not able to escalate to root, so you've got the password, but you're still kind of a limited user, keychain access is a great way to get yourself onto other systems. So the keychain in Apple is a database that is full of all of your passwords, your shared keys, your certificates that you might use to authenticate to like a secure website, all kinds of identity stuff. It's a really, really cool resource to pull clear text passwords out of. So here's a couple of different ways that you can interrogate that database. So find internet password, just pass it the name of a URL. If it exists and you have that password from the user, you can pull that out in clear text. You can also dump the keychain out into a text file. So Apple does have a nice little pop-up box that comes up and says, hey, this program wants you to get access to your keychain. Is that cool? And you can't actually interact with that through AppleScript anymore. You used to be able to. There have been some bypasses using things like mouse keys, which is like an accessibility thing where you can move the mouse around with your keyboard and click. But some of those have been patched. But if you have an old system, definitely watch out for these, because you can do a lot of evil with it. The easier way to mess with the keychain is just to steal it. So you can just copy that file, move it onto another Mac, and you can just open it up in the keychain utility. It's going to say, hey, what's the password for this keychain? You give it to them. You have the entire keychain, all of the passwords in clear text, all of the locations that they're accessing, etc. So looking for any kind of process that is referencing one of those keychain databases is a great way to find someone trying to monkey with this, or just looking for any kind of file modification to one of these databases is a great way to catch this. All right, so lateral movements. So moving from one space to another. You're probably familiar with PSExec if you've done anything with Windows systems. It's a great administrative tool. It's a great tool for running code on other machines as long as you have admin. It's a great way to escalate yourself to system on any machine you want. So some of that functionality you can find in AppleScript, again, because AppleScript can do everything. So here is a remote command to open up a terminal, SSH into another system, and then run a script on that system. Now, you might say, like, why would I not just SSH natively? You can pass like a bajillion systems into this one. So if you want to run through every single system you think you might have access to, it's very simple to script that through this. So here is an example. So the terminal boxes are on the host machine. The underlying box is a separate VM. So we've popped up this terminal, prompted for a password, which you could pass via AppleScript if you want to do it in clear text. We call the application, and now we have calculator on the victim machine. That could be anything. You could run any shell script you wanted to, any Python script, et cetera, et cetera. So a lot of opportunity for bad behavior there. Once you have gotten that kind of access, you can actually make it a little bit easier. So you can enable what they call remote Apple events. So basically it just tells the system, hey, listen out for any kind of Apple script from remote systems. You can secure that to a single user, or you can just say every user by default can send Apple script, which is kind of horrifying. But once you have that, now you can do something like this command here, where it says, hey, tell this application of this remote system to do a thing. And that can be literally anything you can think of. You can just say, hey, tell it to run a shell to open up a reverse shell back to my C2, etc. And then down there, that's where the remote Apple events can be toggled on and off. You can also, with the Kickstart utility, you can also turn that on remotely through like an SSH session. So a couple ideas, detection ideas. So looking for any kind of OSA script with network connections. For the most part, these things are going to be localized to the system. You can also look for any of those that are passing a do script or do shell script on the command line, because that's you can wrap a command in Python, in Bash, in OSA script, like have multiple layers to really obfuscate what you're doing. So. A couple of things on persistence. So we'll look at startup folders. If you're familiar with like the startup folder on Windows, you drop a binary into it, it starts up with the system. There's a library startup items that's been deprecated, and it doesn't exist on new systems, but you can create it, and it's still, Apple still honors it. They're like, oh, I need to do this thing. So any kind of file modification to that folder is suspect, because you either have some very old software or you have someone who's trying to do something they shouldn't do. Services, kind of similar to launch daemons. So launch daemons are not dependent on a user being logged in. They just kind of run on their own, which is different than launch agents, which are kind of more like run keys, the run once keys, which can be associated with an individual user or any user that logs on the box. So if somebody logs in, this launch agent starts. And it can be restricted to a specific user if you want. And then you have scheduled tasks, cron jobs, again from the Linux world. Schedule anything you want to run at whatever time. Every user has their own cron job. So if you log in as root and you say, let me look at my cron tab, there's no jobs, there's no remote tasks, there's no scheduled tasks. Not necessarily true, because every user could individually have their own. So you have to kind of iterate through all those cron tabs. And then launch CTL is kind of an interesting persistence mechanism because it allows you to run a persistent job that will kind of disappear once you reboot the system. So what this looks like, I'm going to start a job for a not evil Pi script. Just this pops up a box that says, hey, Python's running on your machine. I'm not going to execute anything else. I close that, and it's going to pop back up. And it will just keep doing that perpetually until you either remove the job or you bounce the box. So if you have something that you want to run on a victim machine, you want it to run until it's complete, that's a good opportunity, because then you don't have to clean up behind yourself. It just kind of disappears. All right, so we've gone through some of this tradecraft. What are some tools that you can use to start collecting the information? So OS Query is a popular utility developed by Facebook. It's used to retroactively query systems. So basically, it's looking for files on disk, for configuration files, etc. It's not really great for real-time monitoring, but it's an excellent tool for gathering forensic evidence. It's local by default, but you can use something like FileBeat or like a Splunk forwarder to take that and shove those logs up elsewhere. Super Audit is another. This was developed by Jonathan Levin, super bright macOS guy. This is real-time monitoring. It collects process, file modifications, netcons, all that good stuff. It can be syslogged out or kept locally. You can get it in JSON or in the format you see down there. It's a really excellent tool. It's free for like a handful of systems. It is closed source, but it is a really neat tool. If you only have a handful of Mac devices to monitor, this is a great option. And then Znumon is like the newest contender that came out earlier this year at a conference. It's an open source project. They're still building it out. It's meant to be kind of a sysmon for Mac. So right now it's primarily process related events. They have recently added some network events. So that's one to watch as well. And a couple other useful tools. So Obdev has Little Snitch, which is probably the most popular firewall for Mac systems, process-oriented. So every process that wants to make a network connection, if it's not already allowed by some rule, is going to say, hey, like your DNS resolver wants to talk to this thing now, or your shell wants to talk to this Russian website or something like that. So it's a great way to find evil stuff and knock it out early. Microsnitch is another cool one. It actually monitors your microphone and your camera. So if one of those things goes hot, it will tell you by either giving you ears or eyes, which is nice because if you're not expecting your camera to go hot and it goes hot, it's kind of terrifying. So, and then Objective-C, I mentioned Patrick Wardle earlier. The Dialib hijack scanner is a great tool. Knock Knock is something that checks like cron jobs, checks other persistence mechanisms, etc. And then last, I created a little tool called Macintosh. It's open source. It is super alpha. It is basically the idea is if you're handed a Mac system and it's like, hey, like see if anything's going on with this, or you're responsible for this thing now. It might take you a while to get approval for some of those other tools to install across your network. This is just a shell script. It has no other dependencies. You can run it. It just uses like basic command line tools to collect all of this evidence and throw it to a file for you. So it's a great way just to kind of get a snapshot of like, this is what I'm working with. So the idea is like, tell me the users, tell me the groups that exist on the machine. What kind of security software do they have running? Are there any kind of possible compromise? Is there any weird cron jobs or any kind of weird launch agents or daemons that are out there? So the idea is just run this, it'll iterate through all that stuff, and it'll give you a nice little thing to start out with. Say, hey, okay, I know where I stand now. So you can find that at the GitHub thing below. This is what it looks like. It just, right now, like I said, it's very alpha, so it just kind of runs through and says, hey, I'm going to do all these things, and then it drops a file in temp. And then you can go and see the code for yourself. Don't judge me. I'm not good at it. All right. So that was like a marathon. Yes? Mm-hmm. Yep. It's kind of noisy. Yeah, because like there's... Yeah, oh, sorry. Yes, so the question was, if I just look for OSA script, is that going to be really noisy? And the answer is yes, because there's a lot of applications, including like Microsoft. The whole Microsoft suite on Mac uses AppleScript pretty heavily to like show boxes or to facilitate things on the back end. So yes, it can be if you leave it unqualified, but just like anything else, like when you're building detections in your environment, they're going to be specific to your environment. So I can give you like a starting place, like I did on some of those slides, but for the most part, like you're going to know what's going to work in your environment. Some people are not going to have software that's going to be a noisy detect for, and they can run that no problem. Yes, sir. Mm-hmm. Yep. So the question is like, what do we commonly see as the initial vector for Macs? So it's kind of the same thing you see a lot of places. So malicious attachments is a common one. Drive-by downloads. Richie in his talk the other day talked about one of the most common pieces of adware/grayware on systems is like the Flash. Because you get a pop-up and say, hey, you need to install Flash. You click on the thing, now you have some terrible like tracking stuff on your system. So yeah, usually it's the common suspects. It's email, it's drive-by download stuff.
Are there any prevention tools you'd recommend? I know people ran AV back in the day. Focus just on detection, or are there good prevention stuff you'd recommend?
So the question is are there good preventative controls for Mac? And there are. I would say that detection is mandatory and prevention is a luxury. So being able to detect something, you're going to be able to cast a much wider net. You're going to be able to find something that if you try to prevent that exact same thing, you might like take business units down. But specifically for Mac preventatives, Santa from Google is a great whitelisting utility. They have some really cool, configurations where you can allow people to upvote. Like, hey, I'm running this thing. It's not allowed. I want to upvote it. Everyone else gets to vote on it and say, yeah, we should allow that. So it makes it a little bit easier. So I'm a big fan of app whitelisting. It's good control. Anybody else? Thank you, guys.